right, let's look at our exam review packet, starting with number 1. Notice that I've said on problems that I mark with a star, I've pointed out how I might change that question and what the answer would be. Because remember, we said for the exam, it's going to be just like these questions, only I'll change an x to a y, or an x-intercept to a y-intercept, or horizontal to vertical, or change the names or numbers or that type of thing. Okay, so for number 1, it says find the distance between these 2 points. So I'm going to call this point 1 and this point 2. So this would be the x for point 1, and this would be the y for point 1. This would be the x for point 2 and the y for point 2. So distance formula will be given to you on your formula sheet. It won't say this is the distance formula. It will just have the formula and you'll have to know what it's for. And so I can go through and say x2 is 7, x1 is 3, and then y2 is 2, and y1 is -1. All right, so if we simplify that, 7 minus 3 is 4. 4 squared is 16. And then 2 minus a -1 is 2 plus 1, so 3 squared is 9. 16 plus 9 is 25, so square root of 25 is equal to 5. All right, then for number 2, find the midpoint of -3, 1, and 5, -7. So again, I would label these points the same way: x for point 1, y for point 1, x for point 2, y for point 2. And then again, the midpoint formula will be given without any kind of label. And so we can say our x values were -3 and 5, and our y values were 1 and -7. So if we add these, that's going to give us 2 over 2. And if we add these, that's going to give us -6 over 2. So 2 over 2 would be 1, and -6 over 2 would be -3, and that would be my midpoint. All right, then for number 3, we're doing order of operations. So order of operations, we're going to do PEMDAS, so parentheses first. So if we simplify inside parentheses, 2 squared is 4 minus 1 is 3. So you can see right here we've done our parentheses. All right, we don't have any exponents, and so then we're going to multiply and divide from left to right. So 12 divided by 3 is going to be 4 times 6 minus 2 times 3. And then 4 times 6 is going to be 24. And remember that you have to do the multiplication 2 times 3 before you do the subtraction right here. So we would have 24 minus 6, and then 24 minus 6 would be 18. For number 4, the equation of any horizontal line is always going to be y equals something. So it says the horizontal line passing through 2. And so that would be y equals 2. So here's what I mean with the little asterisk. Like I just came over here and said, if instead of me asking what's the equation of a horizontal line through 2, if I said what's a vertical line through 2, that answer would be x equals 2, just so that you have both concepts for that type of a problem. All right, then number 5, it says determine the slope of the line that passes through -1, 6 and 5, -6. So again, I'm going to call this point 1 and this point 2. So this is x for point 1, y for point 1, x for point 2, y for point 2. And again, this formula will be given with no label. So we're going to say y2 is -6 minus y1 is +6. And then x2 is 5 minus x1 is -1. So -6 minus 6 is -12, and 5 plus 1 would give us 6, so that would give us a slope of -2. For number 6, it says, what's the slope of a vertical line? So remember that a vertical line, we said you can't ski that. That's not a slope, that's a cliff, right? So that's no slope or undefined slope. They could write it either way. That means the same thing. That is not the same thing as zero slope. The slope of a flat horizontal line has 0 degree of inclination. So if I had asked you for horizontal, then that would have been 0. All right, then for number 7, so for number 7, it says find the equation of the line that passes through the point 4, -1 and has a slope of 1/2. All right, so we're going to start off with either y equals mx plus b, or if you like y minus y1 equals m times x minus x1 better, that's fine too. But I like y equals mx plus b better, and the majority of you were using that when we did that type of problem. So I'm going to work it that way. So to begin with, I'm going to put 1/2 in for m. So I would have y equals 1/2 x plus b. So the only other thing I need is b, and that's why they give me this point right here. I can put -1 in for y, and I can put 4 in for x, and when I do, the only unknown will be b, and I'll be able to solve for it. So 1/2 of 4 is 2, and then subtract 2 from both sides, and we'll get b equals -3. So now I can say my slope was 1/2 and my y-intercept was -3. Now, if they ask me to give my answer in slope-intercept form, that's my answer. But if you look at your answer choices, they are more like standard form where you don't have any fractions and you've got everything over on one side set equal to 0. So if I go through and I want to get rid of this 1/2, then I'm going to multiply both sides by 2. So if I do that, that's going to give me x minus 2y minus 6 is equal to 0. Sometimes in standard form, you'll see it written this way. Sometimes in standard form, the 6 will be on the other side. It's different with different textbooks. So just you can look at the multiple choice answers that you have and just find the one that matches your equation. All right, then for number 8, find the y-intercept. So remember, in a y-intercept, x is equal to 0. So if I put 0 in for this x right here, that's going to leave me with -7y is equal to 21. So divide both sides by -7, and we'll end up with y is equal to a -3. If instead I had asked you to find the x-intercept, you would have just put 0 in for y. So if you had put 0 in for y, you would have had 3x equals 21, so x equals 7. All right, then for number 9, we are solving this equation that's got rational expressions in it, right? So remember, our magic trick to make all the fractions go away was to multiply by the least common denominator. So I have an x minus 5, an x plus 5, and then this factors down to x plus 5, x minus 5 as well. So my least common denominator is going to be x plus 5 times x minus 5. So we're going to multiply both sides by that least common denominator. Okay, so let's write it out down here. We're going to take the least common denominator, multiply it by the first term, plus the least common denominator multiplied by the second term equals the least common denominator multiplied by that term. So again, we're going to multiply every term on both sides by the least common denominator. So you can see the x minus 5's drop out, and that's going to give us x plus 5 times 5. Here, the x plus 5's drop out, and that's going to give us x minus 5 times 1. And then here, everything drops out, and that's just going to leave us with 2. So here, let's distribute. So I'm going to have 5x plus 25, and then plus x minus 5. So combining like terms, 5x and x is 6x. 25 minus 5 is 20. So let's subtract that 20 from both sides, and we'll have 6x equals -18. Divide both sides by 6, and we'll have x equals -3. And if we check to make sure that we don't have extraneous roots, what gave us an extraneous root was when we got 0 in the denominator. So my answer couldn't have been 5 or -5 because that would have given me 0 in the denominator, but everything else is fine. So this is a solution, not an extraneous root. All right, then for number 10, it says solve the quadratic equation by any method. Now that one won't factor, so you could do completing the square or quadratic formula, but remember that you have your graphing calculator for this entire exam, so you could use the quadratic program on your calculator. So all you need to do is hit program and click on quadratic, and it will ask you what's a, b, and c. Okay, so a is the number in front of x squared. So our a would be 1. B is the number in front of x, so that would be 6, and c is our constant. So if you just tell it a is 1, b is 6, c is 2, then it'll pop out your answer. Now remember, you're going to get 2 answers, and sometimes one of them scrolls off the top of the screen where you can't see the whole thing. So on your calculator, you might be looking at -3 minus the square root of 7, and you can't see the second answer that was up above it. Well, remember that anytime we do quadratic formula, negative b plus or minus the square root. So it's always going to be the other answer that's scrolled off your screen that you can't see is just the plus one. So all we have to do, if it's the calculator is just showing us the minus one, all we have to do is just remember that's always a plus or minus in front of our radical to get our two answers for our quadratic. All right, then for number 11, they ask us to solve, and we have four terms here. So when we have four terms, we factor by grouping. If it won't factor by grouping, we have to do the P over Q stuff that we were just doing. But this one will factor by grouping if I group my first two terms and I group my last two terms. So these first two terms, I could take out an x squared, and that left me with x minus 3. Over here, I could take out a positive one or a negative one, but remember, I need these to match. So I'm going to take out a negative one. And when I do, then these terms match. So if I take out that matching term, that x minus 3, literally put your finger over this one and your finger over this one, and you can see what you've got left is x squared minus 1. All right, let's set each of those equal to 0. So we're going to set x squared minus 1 equal to 0 and x minus 3 equals 0. So I could add 1 to both sides, and then to get rid of the square, we take the square root of both sides. Don't forget to put in your plus or minus. So we'd get plus or minus 1. You might have looked at this as a difference of squares and said, hey, that's x plus 1, x minus 1. That would work as well. That would also get you the positive 1 and negative 1 solutions there. And then, of course, this guy add 3 to both sides, and we'll get x is equal to 3. So our three answers would be positive 1, negative 1, and positive 3. And again, that's a degree of 3. So we should be getting 3 solutions. All right, then for number 12, they ask us to solve this radical equation. So remember, to get rid of a square root, I'm going to square both sides. So the square root and the square would cancel each other out and leave me with 2x plus 7. And then over here, 2 squared is 4. So to get x by itself, subtract the 7 and then divide both sides by 2. And we're going to have x is equal to negative 3 halves. And if we plug that back in, 2 times negative 3 halves is negative 3. Negative 3 plus 7 is 4. Square root of 4 does equal 2. So that is an actual solution, not an extraneous root. All right, then for 13, we have an absolute value equation. So with absolute value, we take whatever's inside the absolute value and set it equal to a positive and a negative of what's on the other side. So we set it equal to a positive of the x minus 8 that was on the other side and a negative of the x minus 8 that was on the other side. So let's distribute this negative, and that's going to give us negative x plus 8. All right, so if we solve each of these, when you distribute the positive, it just stays the same, x minus 8. So let's get all of our x's on one side and all of our numbers on the other. So I'm going to subtract x from both sides. So 3x minus x is 2x. And then subtract 2 from both sides, and I'll get negative 10. Divide both sides by 2, and I'll get negative 5. All right, and then over here, get all my x's on one side. So add x, and that's 4x. And then subtract the 2, and that's 6. So divide both sides by 4, and we'll get x is equal to 6 over 4 or 3 over 2. Now, when I go back to check my answers, if I take this negative 5 and I plug it back in, I have 3 times negative 5 is negative 15, plus 2 is negative 13. So the absolute value of that would be positive 13. If I plug negative 5 in over here, I get negative 5 minus 8. That's a negative 13. Positive 13 doesn't equal negative 13. That is not a solution. That's an extraneous root. All right, if I take 3 halves and I plug it back in, 3 times 3 halves is 9 halves, plus 2 is going to be 13 halves. So the absolute value of that is 13 halves. But over here, if I take 3 halves and I subtract 8, that's 3 halves minus 16 halves. That's negative 13 halves. Positive 13 halves does not equal negative 13 halves. And so that is also an extraneous root. So if the only solutions that I got don't work, then that means I don't have any solution for this problem. All right, for 14, we've got 3 minus 2x is less than or equal to 9. So with an inequality, you're going to solve that just as if that was an equal sign right there. So I would subtract the 3 from both sides, and then I would divide by negative 2. So here's the one thing that's different. When you divide both sides by a negative or multiply both sides by a negative, you have to reverse this inequality sign. All right, and then we gave our answer in interval notation. So remember the smallest number on the left and the largest number on the right. Because this had an equal to with it, we're going to use a bracket. If it didn't have an equal to, we'd use a parenthesis. We can never equal infinity, so we always put a parenthesis with infinity or negative infinity.